This is Euclid Book 10, and it is proposition number 88. We're going to find the fourth apotome. Let a rational straight line A be set out. That's this one right here. And BG commensurable in length with it. Okay? So, this is commensurable with that. Therefore, BG is also rational. This is a rational line. Let two numbers, DF and FE. Where is DF? That's this one right here. Where is FE? This is right here. They're going to be set out such that the whole such that the whole DE, this is the whole DE, has not to either of the numbers DF or EF the ratio which a square number has to a square number. Okay? So, this does not have a ratio to this, which is a square number to a square number. This does not have a ratio to this that a square number has to a square number. Let it be contrived that as DE is to EF, as this is to this, so is the square on BG to the square on CG. Okay, so we've got a ratio here. As this is to this, so is this is to this. That's by Euclid Book 10, proposition number 6, Purism. Therefore, the square on BG is commensurable with the square on GC. So these are commensurable. This is by Euclid Book 10, proposition number 6. But the square on BG is rational. Therefore, the square on CG is also rational. Therefore, this line right here is rational. Okay. Now, since DE has not to EF the ratio which a square number has to a square number, that we're referring now to this and also to this, the whole line to this part. Therefore, neither has the square on BG to the square on CG the ratio which a square number has to a square number. This does not have to this the ratio which a square number has to a square number. Therefore, BG, this line right across here, is incommensurable with CG. That's by Euclid Book 10, proposition number 9. And both of these lines, this line here and this line here, they're both rational. Therefore, BG and CG are rational straight lines commensurable in square only. Therefore, this is an apotome. BC is an apotome. That's by Euclid Book 10, proposition number 73. Now let the square on H, there's the square on H, be that by which the square on BG is greater than the square on CG. What does that mean? You add these two areas together, you get that. Since then, as DE is to EF, as this is to this, so as the square on BG is to this. Therefore also convertendo, as ED, as this whole line here, is to DF, so is this right here to this. And no, that's wrong. Try that again. As this is to this, so is this is to that. That's by Euclid Book 5, proposition number 19, Purism. But ED has not to DF the ratio which a square number has to a square number. This does not have to this the ratio which a square number has to a square number. Therefore, this does not have to this the ratio which a square number has to a square number. Therefore, the length of GB, which is this one right here, is incommensurable with H. And that's by Euclid Book 10, proposition number 9. And the square on BG, which is this right here, the square on BG is greater than the square on CG. This is greater than this by this. Therefore, the square on BG is greater than the square on CG, but the square on a straight line incommensurable with BG, and the whole BG is commensurable in length with the rational straight line set out. This is commensurable with this, line A. Therefore, BC is the fourth apotome. This is the fourth apotome. This is by Euclid Book 10, third set of definitions, number 4. Therefore, the fourth apotome has been found. Alright. I will tell you more in a future video, so I want you to stay tuned.